Mathematicians, here are your notes for 4.3 talking about relations. So before we get started, I would like you to complete the bell work, which is the what I think section of this table down below. Go ahead and take just a minute here, pause the video, fill that out, and then come on back and we'll work together. Alright, hopefully you took a minute and filled out the what I think to see what each of those terms meant to you before we even start. Today's goal is to be able to define a relation and explain its characteristics. But before we get started, let's see a real life, example of what we think a relation could potentially help us to understand. So a person playing racquetball uses 4 calories per hour for every pound they weigh. Make a table to show the relation between weight and calories burned in 1 hour for people weighing 100 pounds, 110, 120, or 130 pounds. So let's go ahead and do that. If I just make a table, and I'm going to make one this way, I'm going to put weight on top, and I'm going to put calories on bottom. It says our first weight is 100 pounds, and it says they use 4 calories per hour per pound. So if this person weighs 100 pounds and it's 4 calories per pound, we just do an easy multiplication by 4 to get 400 calories. Sorry about that. The next weight we have is going to be 110 pounds. So therefore our next calorie set would be 110 times 4, leading us to 440 pounds. Go ahead and just take a quick second to think what the next 2 numbers might be. Alright, if you've given it a shot, we're going to go up to 120 next. When we multiply that by 4, we get 480 calories. And then finally, at 130 pounds, 130 times 4 is going to be 520 calories. Now, what we've just created is a relation. So using this idea in this real world example, let's talk about math. Whatever you thought your relation was, don't change it. I think I've failed to mention that in other videos. Whatever you have in the what I think column should stay there even after we fill out this what I know. It's okay to be wrong, but I want your brain to be really primed to be thinking about these words before we start filling out actual definitions. So that's the whole point of this table. If you're wrong to start out with, that is totally okay. So in our case, a relation shown up above by that example, I like a good definition for that to be related x and y variables. Related x and y variables. Now, if that doesn't make as much sense or you need a more concrete example, a second definition and maybe a more working definition would be a set of ordered pairs. Ordered pairs. So if I said I have 3 points, I have 1, 2, 3, 4, and 5, 6, that set of ordered pairs would be considered a relation. It's also a set of related x and y values because each point has a related set between the x and the y. Next up is something called the domain. So the domain of a relation is going to be all possible x values. So if I have a ordered pair 1, 2 and an ordered pair 3, 4, my domain would be 1 and 3, as those are the possible x values given. The opposite then, or the next one, would be range. So if the domain is all possible x values of a relation, a range is going to be all possible y values of a relation. So I'm going to use that same exact example. I have 1, 2 and 3, 4. And my range for that relation would be 2 and the number 4. Hopefully you can't hear that crow in the background. I'm making this video with my window open, so I apologize if that's distracting anybody. All right, next up is mapping. So mapping is exactly what it sounds like. If you think about a map that shows you where to go or the roads, things like that, it's the same thing in math. All it is a visual representation of a relation. So it's a visual representation of these three up here. The last thing is something called an inverse. And much like it sounds, it is just the inverse of a relation. Without using that word specifically, though, it is a reversal of the x and y values. X and y values in a relation. And an example of this would be taking 1, 2 and changing it to be 2, 1. All we have done is take the x and put it where the y was, take the y and put it where the x was. So there are your definitions. Now let's start to actually use these a little bit. Our first example says express the relation, as those coordinate points, as a table, a graph, and a mapping, and then state the domain and range. Quick thing I want you to notice, when we have a relation or a set of ordered pairs, they're indicated as a relation by these wavy or these curly brackets. I have a really awesome trick if you want to learn how to draw those more quickly and accurately each time you do it. So if you're interested in that, come see me. But let's jump right in. If we're given our relation to start off with, let's create that table. We don't have to create it horizontally. This time we can do it vertically because we do have the space. I'm going to indicate my left side is x, my right side is y, much like those in-out machines that you used to see. You get a value in, it kicks a value out. And in this case, it's really, really easy to go from a relation to a table because all we're doing is putting the x where the x is, putting the y where the y is. We've gotten rid of the parentheses and the comma, and we're good to go. However, we do need to do it with all of our points. If this is the entire relation, we have to make a completed table. Okay. Next up, we just honed our graphing skills in Chapter 3, so I hope those are fresh in our mind. A graph is just putting those points on. It doesn't mean connecting them or putting excess points on. We're just going to make another visual representation. So my first point is at 1, 1. I'm not going to label this one in this case. 0, 2. I'm not going to label that either, not unless it specifically asks for it. I apologize for that noise in the background. Let me take care of that. And then my last point would be 3, -2. Again, I don't need labels as long as it doesn't ask for it. All right, we're familiar with tables, we're familiar with graphs. Mapping is the new one. So a map looks like this. We're going to have one oval that represents the x values, and we're going to have one oval that represents the y values. And you don't have to label these, you just have to draw them. And all a mapping says is much like a table. If my x value is 1 and my y value is 1, I'm going to create that pair, and then I'm going to indicate that those two go together. You can put an arrow or just a line as long as it's clear that those two values connect. They don't have to be in any certain order. As you can see with our table, we didn't go in numerical order here. We didn't go 0, 1, 3, so we don't have to do it in mapping either. Now, the other thing I'm going to do here is I'm going to go 0, and then I'm not going to put 2 directly across from it. I'm actually going to put it down. You do not have to do this. This is not necessary, but what I'm showing you is that it is still technically correct if you see other maps that look like this. It is okay for our lines to cross. So for my last point, 3 is my x and -2 is my y. And in order to connect those, I have to cross my lines. Again, not necessary, but you will see it, so I want to prepare you for that. And then I know that domain and range can be kind of hard for people to remember what they mean or to understand them, but once you get it in your head that D comes first in the alphabet, R comes second, X comes first in the alphabet, Y comes second, we just learned what they are. Domain, your x values. That's all it is. Don't make it harder than it has to be. Your domain is going to be, and you can list these down or you can list them next to each other. So 1, 0, 3 are my x's. 1, 2, -2 are my y's, or my range. I can put them in order. I can put them out of order. It just depends on what the example asks for. In this case, it did not specify. All right, let's go to the back and complete that table. So this is a much bigger table, and all this basically says, let's move this out a little bit for you. There we go. Use the example from the other page to help you. If you need to flip back and forth or go back in the video to kind of fill this out, that's okay. But as you'll see, each row has one item filled out. This one has a table, this has a map, and this has a graph. Using that one piece of information, we have to fill in the 6 other missing pieces. So if you feel comfortable right off the bat, pause the video, give it a go, and then come on back to see if you've got it correct. If you're not quite ready, we can do another one together. So I'm going to let them pause that. For the rest of us, let's jump back in. So for this one, we have a table of x's and y's. I do double check to make sure that they're in the right order and that no one's trying to trick me here. Since my x's are on the left, my y's are on the right, I'm good to go. My relation, remember, the representation of that is just the ordered pairs. So I'm going to take this directly out of the table and I'm going to turn it into ordered pairs. -3, 5. Ooh, that's a rough parenthesis. -2, -1. 1, 0, and 2, 4. Just like that. The graph, I apologize that I didn't put a coordinate plane in here for you. But yeah, go ahead and create your little graph. I go about 5 tick marks on each side. Okay, -3, 5, boom, boom. Again, I'm not going to label these. -2, -1, 1, 0. I'm going to make that one really clear since it is on an axis. 2, 4, and there is my graph. Remember, you can use context clues at any time, so if you forgot what a map was, hey, look at that! I gave you an example down here so you remember that it's the 2 ovals. They do have their x's and y ovals labeled. If you feel more comfortable, go ahead and do that. Otherwise, I'm just going to do these in the order that they are in. -3, -2, 1, 2, 5, -1, 0, 4. Boom, boom. Oop, that got rid of the negative. Got to put it back in there. And there's my map. The other thing I like about going from a map to a domain is that I've literally already got my domain and my range separated into ovals. So to put it in the domain, all I have to do is copy it directly from the left oval and copy it directly from the right oval. 5, -1, 0, 4. Again, they're not in any specific order. We did not do the inverse on the last page, but remember, all that does is it takes the relation and it flips it, takes it backwards. Whatever was the x becomes the y, whatever was the y becomes the x. So in this case, -3, 5 becomes 5, -3. -2, -1 becomes -1, -2. 0, 1, and 4, 2. Just like that. Alright, if you followed along with that one, I would like you to pause now and try the next 2 on your own. And then we will come on back together and do the last 2. Alright, hopefully you had time to fill that table out. Come on back, let's do it together. Now you can go in any order, you can keep going through to the right and then go back and do the left. I personally find that if I have a relation to work with, it's easier to just fill everything in. So I'm going to go ahead and do that. I notice my -1 is connected to my 0. It's not connected to the one right across from it. That's not what the arrow indicates. That's also why I like to do my relation first, because I can be really careful about what connections I'm making. So -1, 0 is my first number. 2, -8 is my second, 4 comma negative 1, and 5 comma 2. From there, I can create everything. So I'm going to stop talking now and just go ahead and write things out. Notice I'm only putting tick marks on as necessary. I don't put a ton on every side because I don't necessarily need them. Most of the time I will provide you a coordinate plane to work with. Alright, next up domain, again taking it directly out of that left circle. Negative 1, 2, 4, 5, negative 8, negative 1, 0, 2, and then of course the inverse. You could list these side by side too. They don't have to go up and down like this vertically. This is just what I do for space. Alright. If you have any questions on that one, definitely let me know. Otherwise, I'm going to look at this last one. This one's a little tricky. There are no numbers to start out with. But again, I like to start with my relations. So I'm going to go in the order of the quadrants. Here's my origin. Let's just make that really clear. Notice that's not a point that I'm including. That's just me telling myself that's where I'm going to start. 2 comma 1, 4 comma 3, negative 4 comma 0, negative 1, negative 1, 0, negative 2. Alright, table 2, 4, negative 4, negative 1, 0. Oval 2, 1. I like to connect these as I go to. Maybe I didn't in the other one. Again, it doesn't matter as long as you make sure you connected them to the right thing. Sometimes I do like to mix it up just to show that I do know how these maps work and that they do not have to connect straight across every time. But again, not completely necessary. Alright, 2, 4, negative 4, 0. Oop, I put that one in the middle for some reason. That's okay, that gives me a chance to show you that they don't have to go in the order here, that they go in the order over here, because this is just asking you what are the possible values, not what are the possible values in the correct order. And last up, let's reverse those. 3, 4, 0, negative 4. Notice the signs don't change. I'm not suddenly negative 3, negative 4. I'm not flipping the sign from the left to the right. The numbers stay the same. They just switch positions. Negative 1 stays the same. And there it is. So basically what this all shows you is that we have a lot of ways of talking about relations, but at the end of the day, all a relation is a connection between two numbers, an x value and a y value. Often a relation will have multiple sets of numbers involved, but they don't necessarily have to either. Again, I want to reiterate, when we graph these, no need to connect those dots. We don't have numbers in between them that would indicate that, oh yeah, between negative 1 and 2, there's another number we could connect. No. These are all discrete. They're individual dots. They're not related to the other numbers right now. They might be later, but not right now. If you have any other questions, go ahead and let me know.